My name is Ben Clarke, and alongside Bryan McAleenan, we'll be presenting our Nepal Hydroelectric Turbine project in collaboration with Engineers Without Borders Ireland for the World Technology Universities competition. Our project focuses on the design and development of a low-cost hydroelectric turbine for rural Nepal, aimed at providing reliable, off-grid electricity using the natural flow of rivers and streams. From the beginning, our goal was to create a solution that was not only technically effective, but also sustainable, affordable, and genuinely impactful and practical for the rural communities it is intended to serve. Project was to design and develop a low-cost hydroelectric turbine specifically for rural Nepal. The system is designed to generate electricity using natural water flow from rivers, making use of a renewable and locally available energy source. A key design priority was ensuring the turbine remains simple and durable, so that it could operate reliably in harsh environmental conditions, including seasonal weather changes like monsoons. Focused on making design easy to manufacture using basic tools and methods, as access to advanced equipment in rural areas is limited. The aspect was the use of locally available materials, which supports easy repair, maintenance, and long-term usability. The design was developed to be practical, accessible, and usable by local communities, rather than relying on specialist knowledge or expensive imported parts. Our project strongly aligns with several UN Sustainability Development Goals. Firstly, SDG 7, Affordable and Clean Energy, as the turbine provides a low-cost renewable energy solution for off-grid rural communities, helping improve access to reliable electricity. SDG 11, Sustainable Cities and Communities, as the system supports more resilient and sustainable rural communities through local electricity generation. This can improve day-to-day life and reduce reliance on less sustainable energy sources. Finally, SDG 13, Climate Action, as the project reduces dependence on fossil fuels by harnessing clean hydropower from natural river flow. These SDGs demonstrate the project both addresses environmental sustainability and community development. Rural Nepal has strong river flow, which makes it highly suitable for micro-hydro systems. Despite this, many communities still have limited or no access to the national electricity grid, creating a significant need for reliable off-grid energy solutions. Access to electricity can have a major positive impact by supporting lighting, cooking, phone charging, and small local businesses. Beyond this, reliable electricity can contribute to wider social benefits such as improved education, healthcare, and economic development. This background research helped us understand not only the technical opportunity, but also the social and regional challenges faced by these communities. That is why our design also prioritizes locally available materials and skills, ensuring that installation, maintenance, and long-term operation remain practical. For this project, we partnered with Engineers Without Borders Ireland, whose work focuses on developing practical engineering solutions for real challenges in developing countries. Their work is so impactful as that it goes beyond theory. It's about creating solutions that can actually be built, implemented, and used to improve people's lives. Their framework focuses on sustainable, community-focused engineering, which helped us think beyond just technical design. Rather than simply designing the most advanced solution, we focused on creating something that would be realistic, affordable, and maintainable in rural Nepal. Key design decisions were guided by affordability, durability, and ease of maintenance. This directly influenced our choice of materials, our manufacturing approach, and the modular design of the turbine, allowing for easier repairs and long-term use. The result is a practical, community-led engineering solution, tailored to the needs and capabilities of the people it is designed to support.
Hi, my name is Bryan, and I'm going to speak a little bit more about how our design works. So our design operates on a concept called run-of-the-river generation. So this means that it relies on the natural water flow from the river to spin the turbines. So there's no damming involved in the river. This results in a less environmental impact on the local area than the construction of a dam would. And it's also less resource intensive for the rural communities where this would be used. So here are some renders and pictures of our prototype on the right. As I mentioned before, this was designed for rural communities in Nepal. We had to bear in mind the resources and skill sets available in these rural communities. So we designed it to be made and maintained with basic knowledge and tools. We designed it so that it would be useful in situations that would require a secondary source of power, or even just smaller source of power, for example, small amount of lighting or charging tools or other devices. So one of the main benefits of using sustainable and locally sourced materials is that these can be repaired by the people within their communities. They don't require outside skill sets, or they don't have to wait on ordering any parts or maintenance personnel to service these devices. So I'd also like to mention that our design was reviewed by an engineer who works in rural Nepal, who said this design was feasible and well suited for the local area. This can be made, but it could be made more efficient and better suited to the local environment with some minor modifications. Thank you very much for listening to our presentation. Our LinkedIn's are available through the QR codes, and we would appreciate if you directed any questions or queries to these pages.